Hi, now let's look at problem 4-4 in our section 4.1.1. So it says Charles and Amy are part of an environmental club at school. Their service projects for the semester is to get a tree for their school donated and planted on the school grounds. Charles' uncle owns a tree nursery and is willing to donate a 3-foot tall tree that he says will grow 1.5 feet per year. Amy goes to another nursery in town, but is only able to get tree seeds. According to the seed package, the tree will grow 1.75 feet per year. Charles plants his tree, Amy plants a seed on the same day. Amy thinks that even though her tree will be much shorter than Charles' tree for the first several years, it will eventually be taller because it grows more each year. But she does not know how many years it would take for her tree to get as tall as Charles' tree. Will they ever be the same size, and how many years will it take? So our task is we are going to represent this problem with tables, equations, and one graph. So I started making our table here. And we will see that when we're doing Charles's tree at 0 years, it's already 3 foot tall. That's where it was at the beginning. So as the years increase, his tree goes up 1.5 each year. I stopped at 8 really because I was on the edge of the page, and then we'll talk more about that on the next page. And then when we look at when we look at the other tree, right now they're just seeds, and so it's 0 length or 0 height. So every year you'll see that it's going up 1.75. And then by the time it gets to 8, it's at 14. So we know that at 8 years, the second tree is still smaller than the first. So that's kind of a good thing for us to keep in mind as we continue on the next page. So you should pause this to make sure that you have this part written down, because I'm going to flip to the next one. Okay, so Charles' equation, if you remember, it was 1.5 x plus 3 because it was growing 1.5 foot each year, and it was already 3 foot tall. So I, again, really like for my slope to be a fraction, so then I can just count how many to go up and over. So I converted it here, so it's y equals 3 over 2x plus 3. So when I graph that one, I begin at 3. I'm going up 3 over 2. I do that a couple times, and then I draw as straight as a line as I can. And then Amy's, I think was her name, hers is growing 1.75 feet per year, and it's beginning as seeds, so it's at 0. So if it's 1.75 each year, when you change that into an improper fraction, it'd be 7 over 4. And so you would begin at 0, you'll go up 7 over 4, and you'll do that a couple times, and then it's actually even running out of room on the graph too. So I want to run over here to Desmos, and I want to type it in so you can see where they do intersect. That is not what I meant to do. I guess I should pay closer attention. So 3 over 2x plus 1.5. And then doing it again, hers is y equals 7 over 4x plus 0. Okay, so then when you're looking at the graph, you're going to see that it is intersecting right around here. Zooming in may help you see it because they're pretty tight here. That they're going to intersect here. What is that? Anyway, we're going to find out when we solve the equation, but that can show you how, where is the bottom of this? I have it zoomed in so tight. That they are intersecting. Well, that has some intersecting earlier. Did I do something wrong? This is C3. There we go. That looks better. Sorry about that. So you'll see right here that they're intersecting at year 12. Bloopers, but I'm not going to take the time to reshoot it, so you just get a smile at me. So That'll show you where they're intersecting. But it's okay if your graph runs off the page as well. That's totally fine with me. So then use each representation to find the solution. Explain how you found the solution in each of the 3 representations. I ran out of room, but with the graph, it's where they intersect. And where the table, if we would have continued on the other page, they would have had the same number when we got to year 12. On the equations, we can set them equal to each other because y equals this and y equals this. And so we can set those equal to each other and solve them. Now, remembering when we solve equations that have fractions in it, we can multiply by the common denominator and it wipes them all out because 4 times 3 is 12, divided by 2 is 6. So you get 6x. Multiply 4 times 3, you get 12. And then this 4 will cancel, so you have 7x. Subtract 6x from both sides, and you will see that x equals 12. So when we look at, move this little thing over here. So then when we look at number 5, it says, in the previous problem, you wrote equations that were models of real-life situations. Models are usually not perfect representations, but they are useful to describing real-life behavior and making predictions. You predicted when the 2 trees would be the same height. So what would be the appropriate domain and range? Well, for Charles, his domain started at his year 0 and went on forever until the tree gets cut down or blown down or whatever. His range, he never had a range that was smaller than 3. And so it's going to be all of the numbers greater than 3. For Amy, she started again at year 0 and is growing the tree. And since she started from seeds, this should be greater than or equal to 0. So please get that fixed. Sorry about that. And then where can you find the x-intercepts of the model of the graph? In the table or in the equation? It's where x equals 0. So we know that that's at the beginning point. So it is how tall the trees were at the beginning. Now, the bottom says the instructions for the other page to write 1 or 2 equations and be careful or be sure to define your variables. And so that will be on video 3. So stay tuned.